Many of our 3D printers have an LCD display, but have you ever wondered how they work? Well, I'm going to try and explain that using a 3D print on today's Filament Friday. Filament Friday is brought to you every week by the generous donations of my Patreon supporters. If you look closely at my Prusa i3 MK2S display, you'll see each character is made from individual pixels. They're arranged in a 5x8 individual character. So this makes it a character display. Character displays come in different sizes and shapes. They'll have a set of rows and columns. This one's a 2x16, some are 1x16, some are 4x20, but each character has its own location. And each individual pixel within that character can be set or cleared to form just about any character that you want. There are three types of character LCD modules. One is transmissive, which relies on LED backlighting for all its lighting. There's reflective, which relies on external lighting. These work great out in the sunlight and are real easy to see and are very low power. Then there's transflective, which is a combination of the two. I believe this is what's in my Prusa i3 MK2S. It's pretty easy to spot the two. A positive display is a reflective. It's got black letters against a colored background. Where a backlit is a negative display where the letters or the numbers are actually lit up and then there's a different color background. LED displays can sometimes be confused with LCD. LEDs use individual LEDs for each segment. They're very bright and draw a lot of power. But they're not bright enough for outdoor applications. They tend to wash out because the sun is so strong. That's why reflective LCDs are used in watches. The brighter the sun, the easier to read. At night, there'll be a little light on the side. You press a button and it floodlights it, and that's how you can see it at night. So how does an LCD actually work? Well, I'm going to use a 3D print to help explain it. An LCD has two layers of light control film turned 90 degrees to each other, so light can come through on one but gets blocked by the other. Here's a 3D model of the guts of an LCD. The top and bottom are the light control film turned 90 degrees to each other. The twisted columns are the liquid crystal. It's actually twisted to allow light to go through one and then twist and go through the other. They represent the pixels. And here's the actual 3D print. It's got the twisted crystal between the two light control films. In an LCD module, they actually place this on top of a mirror. So now the light can go in, twist, go through the second one, hit the mirror, and then twist back and reflect back out. So each individual pixel glows with light. So now you may be wondering, how are characters formed? Well, that's done electrically. Each individual crystal has electrical connections top and bottom. And when a crystal is energized, it actually straightens out, just like this. So when it's straight, light comes in, but gets blocked by the lower filter and doesn't get reflected off the mirror. So where it's energized, it forms a black dot. And where it's not energized and still twisted, light can go in and come back out. So you have that contrast of blocked and open. And by controlling that electrically, you can form any characters that you want on the LCD display. And here's a side view sketch of an LCD module. Light coming in, a reflector at the back, and light reflecting back to your eye. And here's a typical LCD module. Now this one is a 1x16, so it's 16 characters across and one going up, so they're rather large characters. And this is a positive mode, so letters will appear black, and everything else will reflect through and show this grayish color. So right now everything is being reflected. Now the electrical connections are all handled by this chip that's underneath that black dot called U1. So that makes it easy. Most LCD modules have the same chip underneath, and it's a Hitachi 44780, and it handles all those connections to all the individual crystals. So all we have to do is, through these connections at the top, send the right signals to the U1 chip, and we can display any character we want. The Hitachi 44780 has the full ASCII character map already built in, and there are like 8 locations where you can make your own custom characters if you want. It also maps out the display, giving each character its own address. To make things even easier, software compilers such as Arduino or Great Cow Basic already have LCD commands built in, such as lcd.print or just print. And in quotes, you put the words that you want to display on the LCD. Electrical connections are pretty easy too. There's 4 lines for data. There's one for enable and one for register select. Sometimes read-write is used, but typically that's just grounded. So the only thing you need to add is power and ground, and your connections to the LCD are set. And here's a very similar setup, not the exact same schematic. I'm using a Chipino mini module with a PIC 16F886 microcontroller from Haltronics.com. I've wired it to the LCD through the 6 connections, but I've also wired in a momentary switch to one of the pins. The software is driving the LCD to display the word count, and then also display the variable count, which is the number of times the switch is pressed. So every time the switch is pressed, the microcontroller senses it, updates that variable count, and then updates the LCD with that new value. The software was written with the open source and free Great Cow Basic compiler. I love this for beginners or anyone getting started. It's real easy to use. The top of the program defines the chip, the 16F886, and then it defines the connections to the LCD. You have to tell the software what pins to drive. And then I can use the print command that's within Great Cow Basic. So the real program starts at count equals 0. This is where I define the variable count and preset it to a value of 0. I wait 1 second for the LCD to settle out, and then I do a clear screen. This is a command that's built into Great Cow Basic to clear the LCD screen. Then I go into a do loop and I check the switch if it's pressed. If it's 0, it's pressed, and so I increment count equals count plus 1, and then I wait for the switch to be released. Then I just use the print command to print the word count on a display and then locate to a new spot and print the variable count to show the number of times the switch was pressed. And then loop back and do it again. Now LCDs come in a lot of different shapes and sizes, but chances are you can find a case for it on Thingiverse. I found this 16x1 LCD case by user Digimatic. I really like the way this thing looked and can easily be modified. I printed one out on my Creality CR10 3D printer at a 0.2 layer height, 20% fill, and it came out really nice. I love the quality I get out of my CR10. And the design itself is actually really nice. It's even got mounting posts inside for the LCD, and my LCD lined up perfectly with those posts. The holes are a little small, so I'm not sure what screw he planned to use. I may have to modify that in Tinkercad, but it does have space for extra electronics, and then I can add a hole in Tinkercad for a switch or even for wiring coming out the back. So I can see that this is going to be a very handy case for projects in the future that may need an LCD display. So now you should have a pretty good understanding of how the LCD on your 3D printer works. So if you like this video, check out some of these other videos that are popping up. If you click on those and watch them, it really helps the channel a lot. So that's it for this week. Thanks for watching, and please subscribe. I really appreciate it. And if you can help, $1 a month to Patreon, appreciate that too. I'll see you next time on Filament Friday.